Nestled high in the rugged Swiss Alps lies a mega dam that has stood for nearly a century, silently holding back millions of cubic meters of water, empowering the lives of countless people. Built during an era of burgeoning industrial ambition, this towering structure has long been a symbol of human ingenuity and resilience against nature's unforgiving elements. But over time, the relentless forces of weather and the passage of decades have begun to test its limits, creating a pressing need for renewal. Today, a daring replacement project is underway, and it is one of the world's most challenging and epic construction sites. This ambitious undertaking seeks not just to restore functionality, but to surpass it, blending cutting-edge technology with sustainable energy goals. Yet, the project is fraught with challenges: a high-altitude environment, extreme weather, and the delicate balance of preserving the region's ecological integrity. So what does it take to replace a dam in one of the most remote places on Earth? Join us today as we delve into Switzerland's urgent battle to replace a cracked mega dam. Don't forget to click the subscribe button and like this video, as it's the best way to support this project. Situated at Lake Grimsel in the Bernese Oberland region, the Spittalamm Dam is a critical component of Switzerland's renewable energy strategy. The original Spittalamm Dam was constructed between 1925 and 1932, predating America's Hoover Dam, which was completed 3 years later. At the time of its completion, the Spittalamm Dam was among the world's first large arch-gravity dams, showcasing innovative engineering for its era. The dam stands 134 meters tall and spans 258 meters across its crest. Its curved structure is designed to efficiently withstand the immense pressure of the water it retains. The vast structure was built by approximately 600 construction workers almost entirely by hand. Over the decades, the dam has been integral to Switzerland's hydroelectric power generation, contributing significantly to the nation's energy mix. The dam played a vital role in maintaining a reliable energy supply. However, as the structure aged, concerns about its integrity and safety emerged. A significant crack, first identified in the 1960s, raised questions about its long-term viability. It wasn't just a crack, it was what's called a vertical separation, a significant split where a large section of material had begun detaching from the rest of the dam. Over time, this separation has worsened, raising concerns about the dam's stability, especially in the event of an earthquake. While most earthquakes in Switzerland are so mild they go unnoticed, the one in 1991, for instance, was strong enough to cause building damage. The most alarming scenario would involve a major earthquake striking decades from now, when the vertical separation has grown larger. In that case, part of the dam wall could collapse into the lake, potentially triggering a tidal wave that might devastate the valley below. Despite regular maintenance, the need for a replacement has become increasingly apparent as the crack continues to widen, presenting a potential risk to the surrounding environment. You might be wondering why they didn't simply fix the crack or replace the section that's pulling away. Initially, that was the plan, but it was deemed too dangerous. Investigations revealed that such repairs could trigger an alkali aggregate reaction, potentially causing long-term damage to the concrete. Completely dismantling the dam wasn't feasible either, as it would require redirecting all the water elsewhere. Additionally, since the lake plays a key role in hydroelectric power generation, removing the dam would create a massive gap in the energy supply. This left them with only one practical solution: construct an entirely new dam in front of the existing one and flood the space between the two. The decision to replace the Spittalamm Dam was driven by multiple factors. The aging dam's structural deficiencies could compromise its ability to hold back millions of cubic meters of water. A failure would have catastrophic consequences, including flooding and the loss of hydroelectric power capacity. Advancements in engineering and material science have made it possible to construct more efficient and durable dams. A modern replacement ensures improved safety standards, greater water storage capacity, and better resilience against natural and human-made stresses. The long-term economic benefits of a new dam outweigh the costs associated with maintaining and retrofitting the old structure. The new dam will also support increased energy output, contributing to the national grid and providing a return on investment over its lifespan. The lifespan of the Spittalamm Dam replacement project, launched in 2019, is a complex undertaking. In terms of cost, the $140 million price tag for the new dam is relatively modest for a mega project. However, the scale of the endeavor and the obstacles faced by the teams are enormous. The construction process began with carving out space for the new dam. Since the site is solid rock, the team had to use controlled explosions. This task was extraordinarily challenging due to the need to work right next to the base of the old dam, which holds back a massive lake. Executing this without causing damage to the existing structure is one of the most delicate construction feats ever attempted. The new dam is a double curvature arch gravity structure standing at 113 meters high and spanning 212 meters wide. Building it will require approximately 215,000 cubic meters of concrete. The design allows for potential future height increases, enabling expanded water storage in Lake Gimel. The new dam is being constructed directly in front of the existing one to minimize disruptions. Lake Gamsil continues to function as a reservoir throughout the construction period, ensuring ongoing hydroelectric power production. The biggest challenge of this project is ensuring that the old dam wall remains intact and secure. All the work is being carried out directly in front of a fully contained lake, so engineers must guarantee the wall's stability throughout the entire construction process. Even while conducting blasting operations nearby, every step must prioritize the safety of the existing structure. As you can imagine, this creates enormous pressure to work quickly and flawlessly. One of the major hurdles is sourcing all the concrete needed for the build, but the team has devised a smart solution. A dedicated on-site concrete plant has been set up for the project, using granite extracted during the construction of the nearby power plant to produce the required material. Once the construction of the new dam is complete and operational, the existing dam will be preserved and eventually submerged, maintaining its historical significance while the new structure takes over its functional role. The construction of the new dam is expected to span 6 years, with completion anticipated by autumn 2025. The original Spittalamm Dam is a testament to early 20th century engineering and reflects the ingenuity of its time. By preserving the old structure beneath the reservoir, the project honors its historical importance while embracing modern advancements. This dual approach highlights Switzerland's commitment to progress and heritage in constructing large-scale infrastructure. The infrastructure project in the Swiss Alps presents unique challenges that require innovative solutions. The dam site, located 2,000 meters above sea level, is subject to harsh weather conditions, including heavy snowfall and extreme temperatures. These factors limit the construction window to only a few months each year, necessitating careful planning and scheduling. The remote location of the dam site further complicates the transportation of materials and equipment. Helicopters and cable systems are used to deliver supplies, while temporary roads and bridges facilitate access for workers and machinery. Meanwhile, the pristine alpine environment around Lake Gemsil is home to diverse flora and fauna. The construction project must adhere to strict environmental regulations to minimize its ecological footprint. Measures include careful waste management, habitat restoration, and monitoring of water quality. Ensuring uninterrupted operation of Lake Gemsil as a reservoir during construction is critical. Engineers have implemented measures to stabilize the old dam while the new structure is built, balancing safety and functionality. The replacement of the Spittalamm Dam and the incredible feats being accomplished by the construction team despite the overwhelming challenges posed by this stunning yet harsh environment truly showcase the remarkable capabilities of modern engineering and its potential to transform the lives of millions. As this ambitious project approaches completion, its potential impacts extend far beyond the Swiss Alps, setting new standards for hydroelectric power generation, environmental stewardship, and infrastructure resilience around the world. Aging dams face structural challenges similar to those addressed by this project. The innovative methods and technologies used in this replacement effort provide a blueprint for other nations grappling with outdated water infrastructure. From advanced construction techniques to environmentally conscious practices, the lessons learned here can be adapted to similar projects worldwide. What are your thoughts on this dam replacement mega project? Leave a reply in the comments section. Thanks for watching, and see you in the next video.